Okay, here we are, continuing with lesson 6.3. Let's look at how these examples go. So in this first one, we're converting from, let me get my pen ready here, from log to exponential. So just going to use, I want red, the arrow trick, right? So base of 3 to the second power equals 9. That is it. We wrote that log as an exponential. Okay, let's look at the next one. Use your arrow trick. Base of 10 to the second. Okay, that pen is way too fat. Let's try a different size here. So 10 to the negative 2 equals 1 over 100. And once again, remember these should make sense, right? 3 squared is 9. 10 to the negative 2 is the same as 1 over 10 to the positive 2. 10 squared is 100, so that is equal to 1 over 100. So they do make sense. Same thing. We're going from a log to an exponential. So 9 to the second equals 81. So I'm just going to write that log as an exponential function. 9 squared equals 81. Tell you what, pause the video right now, try this one, come back and see if you got it right. Okay, hopefully you paused this and you should have gotten 3 to the negative 2 equals 1 over 9. That is all there is to it. Next, we just have a little reminder. This looks like it got messed up. This is just a little reminder of when we're going between a root and a power. And remember, the bottom becomes the root over here. This is like the root of your flower. Becomes the root over here, and the top becomes your exponent. So this example should have said 16 to the 3/4. So that's going to be equal to, this is going to be my root, 4th root of 16 to the 3rd power. You could also write it as this, 4th root of 16, all of that to the 3rd power. Either way you write it, the 4th root of 16 is 2, so then I have 2 to the 3rd power, and that equals 8. So 16 to the 3/4 equals 8. That's just a reminder because you're going to be using that later. Now this one we're turning it into a log. So we're starting with an exponential and we're turning it into a log. Same thing. We know we're going to have a base 5 here because we always keep the same base. So we want to start with writing the word log. Log base 5 of 125. It's my first arrow there. Equals 3. Right? Log base 5, so just follow your arrows. Log base 5 of 125 equals 3. Remember, my exponent is what ends up on the other side of my equal sign. So over here I'm going to have a log. I'm converting to a log, so log base 27 of 3 is equal to 1/3. Log base 27 of 3 is equal to 1/3. So that's my answer, and this was my answer. Here, still going to a log, so log base 3 of 81 equals, my exponent is 4, remember? Your exponent always becomes what you're equal to over here. And last one, pause the video, try this one yourself, come back and see if you got it right. And if you got this right, you should have for your answer log base 81 of 9 equals 1/2. That's it for examples. Okay, now this says evaluate the expression. So it's an expression right now. It does not have an equal sign, although you can almost think of adding an equal sign and an unknown over here. So let me show you how this works. We're going to use the arrows again. And what we want to do is we want to convert it to an exponential. Okay? And then that will be easier to evaluate. So you want to think of using your arrows, and the question we're asking is 3 to the what equals 243. So you can think like this, 3 to the what equals 243. Well, 3 to the 5th equals 243. So that would be 5. Another way to think about this when you're at this point is wanting to get common bases. So I have 3 to the what, and I can write 243 as 3 to the 5th. So to make these two equal, what I would have to have up here in my empty box is a 5. Either way you want to think about it, both works. Next example, if you want, you can go ahead and put a variable over here because that's what you're trying to find. And then do your arrows. So 10 to the x is equal to 1,000. 10 to the x is equal to 1,000. So remember, we're converting to an exponential when we try to evaluate these. So 10 to the x equals 1,000. What does x have to equal? Well, 10 times 10 times 10 is 1,000. So that would be 3. So the log base 10 of 1,000, let's see if I can erase here and put my answer up here. Log base 10 of 1,000 is 3. Next one. This has a couple of intricate ones. Oh, let's see. Let's try the assigning the variable. So we're going to say x over here. I'm still going to do my arrows. So I have 9 to the x equals 9 to the second power. Well, my x here has to be 2, right, to make these two equal. 9 to the second power equals 9 to the second power. So the answer for this, I don't like that 2. The answer for this is 2. So the other thing I want you to notice, which is kind of a little trick or a shortcut, if you look up here, notice that we have a log with a base 9 here and an exponent with a base 9 here. You can think of those as undoing each other, because remember we said logs and exponential functions are inverses, and when they undo each other I'm left with a 2. Boom, there's the 2. So you can use the same process, or when you look at this one, I'll show you first kind of the shortcut method. This is an exponential with a base 7, and my exponent up here is a log base 7. So my answer to this is going to be x squared minus 1. And now I'll show you how it still works with the arrows. So I'm going to set this equal to, not x, because they're already using x, a different variable. And then, remember, this is starting as an exponential, and I want to convert it to a log to solve it. So I'm going to write log base 7 of y, which is our unknown, is equal to x squared minus 1. So this is our unknown, right? Well, if, oops, I wrote something wrong there. Let me go back here. It's equal to, forgot part of this, it's equal to, so it should be log base 7 of y is equal to log base 7 of x squared minus 2, because all of this is our exponent. So log base 7 of y is equal to log base 7 of x minus 2. So if I want these two things to be equal, our y has got to be x squared minus 1 to make this equal. So you can see that I got the same answer as when I did my shortcut up here. Our think, pair, share. So these are for you to do on your own. And then the idea is to check your solution with your partner. That may or may not be possible because you're doing this on a video, but either way, pause the video and see if you got the answer right. So hopefully you pause the video here, and what you should have gotten here for an answer is 3. So 5 to the what equals 5 to the third? 5 to the what equals 5 to the third? Well, it's got to be 3. Or, with the shortcut method, log base 5, exponential base 5 means they cancel each other out, and 3 is my answer. So over here, exponential base 3, log base 3, those undo each other, and my answer is x plus 2. Okay, that's it for this video, which was evaluating logarithmic expressions. So now you could try in your homework the converting and the evaluating logarithmic expressions.